All right, here we go, folks. Okay, question is up.
Using Kirchhoff's rules, no running in the hallway. Smiley, the apple tastes like soap. Did you put soap on it? Yeah, I watched it. Soap? Why? It's like liquid sand. What?
Whoa, what the heck?
What would you say is Brian just
I missed this.
Yes.
All good sources in parallel?
You might wanna.
Might want to
Yeah.
read up on that.
Yeah.
Finally, can you give me a short of it? Is it just you just add their reciprocals?
If you're
If there's no short of it, don't worry about the short of it.
You'll figure it out.
I'll figure it out. It's
yeah, I'll make sure to expound.
No, that's
Okay. Thumbs up if you have a guess.
Why am I giving a thumbs up? I have no idea how to do this.
I have a better chance than Bradley of getting this one. No idea what's going on. Raisins kill me. I 4? Oh, that's a 1.
Talk to your neighbor.
4 is what I wanted to say.
Oh wait, I think I could have figured that one out.
Yeah. That's what I wanted to say.
I got that.
Okay. Everybody go with 4.
Yes. Could you expound on that?
I will expound on that.
What does expound mean?
Explain in deeper detail.
Expand.
So at this right here, current's going. I3 is going this way. I2 is going this way. I1 is going this way. So what's going in is going out. Okay. Here's the quick. So you look at a loop, any loop, and you first guess which way the current's going. Complete guess. Oh, let me throw this. I did not tell you this. So yesterday we were guessing on the way the current was going. If we guess wrong, the answer will be negative.
Oh, I love when that.
Okay? And if you guessed right, it's positive. Does that make sense? So that's how, like, that's your, like, oh, I got a negative current. Oh, that just means it's going the other way. So,
Yes, you make it positive.
Make what positive?
Make it positive. The correct answer can never be negative. No.
Yeah, so if you're, just take the absolute value of your final answer.
no. I mean, the amount, yes. But that tells you, but the direction, if it ends up positive, if your answer ends up positive, that means you guessed the direction of the current correctly. If it ends up negative, that means it's this magnitude, the current's just going the opposite way.
Smiley, is the skin of this from poison ivy too?
No.
Okay. Because it doesn't taste good.
So you're gonna go, you pick a direction of current.
So it's like up for our one.
Yep. So they are guessed it here. And then you pick a loop and you pick a direction. If you're going in the direction that you would expect to go, that's a positive gain. That's a voltage gain. If you're going in the opposite of that, that's a voltage drop. If you're going in the direction of current through a resistor, that's a voltage drop.
Really? Oh, okay.
Yeah, that's normal.
Yeah,
that's normal.
Yeah, okay.
But if you're going in the opposite direction, gain. So this is like you're climbing up a ladder. This is climbing down a ladder. This is going down a slide. This is climbing up the slide in the opposite direction.
So do I do like? Here, I'm gonna make a conjecture on what I think that's gonna be then. And yeah, okay.
Thumbs up when you have a guess. Have a conversation.
E. Awesome. Okay. Let's go, baby.
Okay.
Bradley, you need to watch the video.
I talked to Sam tomorrow at Purdue.
You need to watch the video.
Okay, good. So
Mr. Battle.
here,
Sorry.
here's a voltage drop. Here's a voltage gain. Here's a voltage drop because we're going the opposite way in the battery. And then here's a voltage gain because we're going in the current's going this way. We're progressing this way. So it's a voltage gain. Okay.
He might be commanding officer. Remember that William kid? That guy with the mango.
What's your slide? Did the last one specify clockwise or counterclockwise?
Yeah.
It did.
Like the last question?
Oh, yeah.
Oh, clockwise, okay.
Then you'll just kind of.
Answer.
Well, that's not the same answer. You go. Counterclockwise.
Oh, yeah.
So, wait. Starting from 14.
Oh, okay. Oh, I'm got
Here's a clock.
Yes.
That's-
It's very smart and wise.
Look at the second hand. Go the opposite way.
It's not E, what? I was banking on that one.
How much physics would normally make sense enough that I'm in Sligo. How much physics usually made enough sense that I can get a 5-minute catch up from Smiley to get the right answer.
Sam,
Talk to your neighbor.
D. Let's go. Let's go.
It's actually A.
No, I don't think that's fine.
Okay. Agree. Voltage drop. Okay, we're going down a ladder. Current's going this way, so we're going in the opposite direction of the current. So we're climbing up the slide. Voltage gain. Here we climbing down a ladder. We're going the opposite direction, and we're climbing up a slide. So all of those, it's just kind of whack. I mean, if you were doing this, I would go clockwise. Yes.
Can we do some letters for our next class? I'm thinking about it.
All right.
We can do a marble one. The marble represents an electron.
Yeah. But then if you change it for electron, it goes like this.
You can go to Walmart.
We gotta make the marble push one.
Wait, electrons will.
Whoa, this still works with the Walmart idea.
Yes!
Send people backwards through the Walmart. They're gonna have more people that want to buy stuff.
Oh, you weren't here yesterday, so you didn't hear the thread I made if people continue the Walmart joke.
What's your threat? Awesome, I'm okay with that.
A is in global.
Yes.
Oh, okay. Yeah. Oh, well, B is. Okay, I just how that works.
Oh, this is technology.
This is weird. B changes.
Okay, we have a guess.
Hey, you don't see.
No.
Yes.
See, you're automatically wrong. You have a certain idea, you're like almost stripping you backwards.
But in this case, if I
There's going to be a stuff across A. And so.
Hey,
I'm just taking a seat though.
Think of it in terms of current.
Oh, whoa, he's already.
And they're identical bulbs, so we can actually use this in terms of current.
Okay. So everybody have their initial guesses.
Oh, yeah.
Okay.
I'm just going to show it.
We'll get there. We'll get there eventually. Okay. So this is.
this is one of those things where you're gonna go step by step, and then I'm gonna be.
Okay. Do you? Oh. We understanding this. Let me. Okay. So all this correct. all this here has an electric potential of 12 volts. Okay. Across the resistor, it drops to 0. Okay. So here, all these have an electric potential of 0 volts. Okay. So the electric potential difference of 12 volts across this is electric potential difference of 12 volts across this. Okay. 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 So tell your neighbor what you think.
We're going deep. Oh no, it is fake.
Yeah, there's no current, so there's no voltage drop.
There's no voltage drop across today.
I'm assuming the blue wire is the one with the switch, considering how it's the one that's not labeled.
Oh,
It would be really stupid if they were asking us the electric potential on one where the electric potential is labeled.
Okay.
We're going to assume it's arcing.
This is the blue. Okay. So correct answer is B. It's just a conductor. There's no. Is you okay with that? There's no current. Now. You now have, so you have 12 volts. When we close that,
I'm so smart. It's guaranteed.
No way.
Smiley, if I get this wrong, I'm dropping class.
That's crazy. Teacher Daniel.
Dang it, I'm still wrong.
that's hilarious.
I'm gonna highlight my bed.
What? All right. So, what do you think? Talk to. Okay. B is correct. Okay. There is no difference in electric potential. Sorry. Oops. Between this and this. There's no motivation. There's no motivation to flow. We can do a loop rule.
Yeah.
Voltage gain. Voltage drop.
Oh, A stays off.
Yeah.
There's no current, so junction rule need not apply because we're adding 0. That's trivial.
Okay. We can do this loop rule. Okay. We could do this loop rule.
Wait, so if I have 2 batteries and I connect them like that, they won't get really hot and burn up? With like wires? You know what I'm saying?
Oh, like
Like battery, connect them.
It's positive and negative to negative.
Yeah.
if you do this,
Let's try
and
it. Yeah,
connect
so I'm
it,
fine if I do that.
you're fine.
And then I switch the wires.
Right.
Well, no, if you swap the wires, you have positive, positive, negative, negative still.
Okay.
That's true.
So
Flip the battery. Flip the battery.
most years people want me to prove it.
Yeah.
Math looks convincing. I just want to.
So come on over here, and we're gonna prove it.
I forgot my popcorn.
I'm sorry, dude.
It's okay. You can make it using batteries.
Okay. So this is gonna be A. This is the thing that we're like, no way. Actually, let's do red.
How is this not?
These tables move.
Yeah, let's not.
Yeah, they do.
They're-
Gotta lock them.
They're on rollers.
Due to some of the forces who's pushing it that way, it's trying to kill me.
Attempted manslaughter or something.
Attempted
That's
manslaughter
just
does not
attempted
make
murder.
Oh, can someone
Daniel, that's
go get my
conspiracy.
computer, my laptop?
Oh, we're gonna record it. Bradley, you're a vlogger now. Yo, what's up, guys?
Yeah, we're gonna be playing some Minecraft. Watch mine as he makes this epic redstone elevator.
Oh yeah.
Oh, that's hilarious, you guys.
What's your gamer tag, Smiley?
And what you guys watch.
I don't know what you guys.
Imagine if just
All
like
right.
This is so
So
awkward.
yeah, you can put
yeah, we all stood in a way.
just place it right over here.
Take care, Tim.
Yeah, who's not here? Of course.
Hi,
Sebastian.
Cora.
Sebastian's here.
Okay. So, Daniel, get out of the way.
Smiley forgets what the circuit looks like.
Well,
Yeah, it doesn't help that we're all standing right in the way.
it isn't the most obvious circuit.
Mhm.
It starts to get very, very hot.
So
Before it catches on fire.
we've got that.
Rarely am I not tall enough to make this work.
So small.
Okay, this is my switch.
Brett's sad. Just
Daniel, can you move your head?
He kind of
Sam?
does, I think. I don't know what your dad looks like. though.
Yep. That's what I'm saying.
the bill.
Okay, yeah,
Yeah.
but facially, no.
I'm going Bradley using move it.
He's got a monocle instead of glasses.
I've met him, he does.
This is really neat one.
I can't have it.
Gravy
Oh, I don't really need to need it. Oh yeah, I do. Tyler has shoulders.
Get out.
Not anymore. No more shoulders.
No shoulders.
Yeah, no matter.
Oh my gosh, I'm finally taller. I block someone's view.
Actually, I'm gonna go 3 volts.
Sam, why are you stabbing your apple?
But now you can see it.
Yo, you gotta.
You gotta plug the battery.
Yeah.
Yeah.
Yeah, and then you gotta.
Your circuit just dropped. Okay.
All right.
We're cooking it.
You. Oh, why is that?
What are you measuring?
Say you gotta eat it.
Why is
now.
what? This is the ultimate.
I think it should just be that connected to that. So red just touches
Wanna
it.
lift that?
We're gonna throw another wire in there.
Oh no.
Oh, okay. Yeah, it's gonna
Well, not when he bites into it.
Oh.
Okay.
All right, guys.
So here's my switch. This, here's my switch. Here's light bulb A.
Yeah.
Here's the right side, the lower right side.
Yes.
Going here, here, here. This is
The big one.
the big one. And then when we connect this,
And we get a really big one.
Nothing happens. Stays off. Okay. Cool with that?
Electricity doesn't work.
Okay. All right.
I would not eat that apple anymore.
Next
I would definitely.
Don't
scenario.
worry, I said we're gonna cook it so it doesn't happen.
It went down.
Sam, you gotta plug it into the.
Yeah, turn that down just
Don't have to wait
on
to
the
turn
other
it
Hey,
on.
one.
Smiley, first science, you mind?
First science.
I don't.
Tyler, can I leave?
Why do you still have the key things in them? Because we're gonna light a light bulb.
Okay. Next scenario.
What is that?
No.
Oh, my grandfather. It was less important.
That was a really good one.
Still gonna
Where
eat
is
it.
I kind of need that back.
You're welcome, Smiley. I didn't
Thanks.
contribute.
Thank you. Good job. Yeah.
Yes. So this union is saying what happens over time.
Why? What?
I like that. I have a hunch. Just go up and take some markers from over there.
Okay. Have a conversation.
Yeah, nothing changed. If you go 21
Yeah, so if you look at the top, right,
Then
you got a
you
12
two
volt
identical
drop.
balls.
Oh, no,
This
what
is
about
12 volt drop.
Go this way, go this way.
So
No,
that's
we
like
think
the entire middle wire is 12 volts, and then the other part is 12
So-
volts.
so
No,
he's
no voltage difference.
The voltage drop across both of these. The voltage drop across both of
But I don't think it's right.
You weren't here yesterday.
I know,
But
I
he's
know.
right.
I can
He's
see
right.
it faster,
It's the still false word.
though. Definitely. I feel like
How does D even conceptually work? Oh,
I said T. I said oh.
Hey, go down that. Oh, on A, it has to climb up the road.
Oh, gravitational potential energy.
Oh.
Yeah.
That actually works.
Well, that works.
the direction is determined by the lengths of the lines. Remember?
No, voltage direction matters, but not.
Walmart, bro, Walmart. Okay, let's go. Walmart. This is like two Walmart.
Well, actually,
No, there's one checkout lane going into both of them.
Two Walmart.
Okay. Have we come to a conclusion? Consensus?
no.
And all of us are equally wrong and right.
Especially those of us who say C.
Maybe they're equally wrong.
All right. So,
I see light bulbs that are turned on.
yep. All right.
They look pretty equally.
So
Sam, that could have been your apple.
we said You all said what?
C.
C?
Well, I see for correct
Okay.
answer. For electrical species.
All right. So,
Equally bright.
so I'm gonna say this is 0 right here. You can pick anywhere around here to be 0. This is like ground, like saying this is ground. So I'm gonna say this is 0 volts. Okay. So you have 12 volts here. You have 24 volts here. Okay. 24. In this loop, this needs to be 12 and 0 for that loop. Everybody good? Okay. So this is 0. This is 12. This is 12.
I don't know why it's not looking so good.
Okay.
What do you guys talking about?
So just like this one, 12 volts, 12 volts, there's no motivation. Don't add them. Okay. They stay on equally bright.
The gravitation thing actually kind of is.
Well, no. Like the shoots and ladders.
You can do shoots and ladders, yes.
Yeah, they're the same height, so it doesn't matter.
Yes.
It's still the same drop.
Yes. Gravitational, yes.
Okay.
That works. Yep.
Soothing my brain.
Anytime that isn't ER. Okay.
Oh yeah.
So you just have to draw the voltage at every point and see what happens.
Yep. You're catching that?
Infinite
Anybody want to see that? Let's see, what is, so over time, what happens?
Well, eventually one of the batteries goes out.
Yeah, so battery goes dead.
Oh, actually?
Yeah.
Oh, okay. Oh, wait.
Yeah. Over time.
Which
Which
battery goes
which light bulb is going to go out first? So let's try that route.
A. Apple.
For a saying.
You know, they're serious, so if one goes out, the other one has to go out.
It's true.
Hey. So, do we actually know which one goes out first?
I do.
Why does this voltage not go this way too? I know what I mean.
So it's an elevation thing. It's an elevation thing. It's not a flow. So current doesn't flow. Sorry, voltage doesn't flow. So it's just an elevation thing. So here's ground zero. We're climbing. Climbing again. Plateaus. Drops 12. So this elevation is 12. This wire. This whole all this is 12. Okay. So here, then it drops to 0. This is 0, this is 0, this is 0. This is 12, like it gains 12. You good with that?
He needs the elevation, like
The electric potential.
you remember the thing with the hill and the sequel?
Yeah, well, what if we bring this to a melt?
Yeah, it's not.
Can you explain it again?
Voltage of batteries goes down over time, right? As you use them? Or is that wrong?
Yes, when it's hooked up to a circuit. Like because of the internal resistance. Okay. Daniel. Question? Emma, do you want me to just do that, like do this again?
Yeah.
Okay. So I'm going to pick this to be my sea level.
No, the time.
Oh, the time. We haven't talked about that yet. Okay. So here, B is going to stay on longer because this is kind of like a backup battery. This is in parallel. Okay. The only reason you'd have batteries in parallel is so that it acts as a backup battery. Like the car I grew up in, the Smiley Mobile. Yeah, it used to be a diesel, and so it had 2 batteries in parallel. I've never seen a car that does it, but this thing is a beast.
I mean, if you're using diesel now, you probably do want that actually.
Yeah. I don't know.
I would assume.
Does it?
I love Smiley.
Okay. All right. So, if anybody wants to see the proof of concept here, this is A. This is B. I hooked this up to 6 volts across here. Okay, so these are my 2 batteries on the right side. And then here's my switch. And I'm going to connect it. This is bulb A, this is bulb B. This is my switch right here. Everybody okay with setup? So when I do that, nothing changes.
Wow. Can we lower the voltage of this to see them kind of progress? Oh, why did that one go down?
Because I changed the voltage on this. I took half of it.
No, as you touch it.
Battery.
Oh, because it counters it? Or?
So see if you can figure it out. So I just moved this to 3. So now these power sources are the same. It was, I had 2 of them.
Oh.
Why does that?
Canceling each other out.
3 volts and 3 volts, 3 volts, no current.
Yeah. Okay. Interesting.
Okay.
I don't get it.
But if that was 6 over there, that would still be lit with 3, right? The backup battery? Because of...
Okay, well, hang on to that thought. That's a good thought. Okay, so I'm going to say that this right here is my negative terminal. I'm going to say that's 0 electric potential. Okay, there's 3 electric, sorry, it has a 3 volts here, 3 volts, 3 volts, 3 volts, 1.5, 1.5, back to 0. Okay. This has, this is 0. This is 3 volts. So this is 3 volts. This is 1.5. So then here's 1.5. When I do this,
This becomes 3 volts.
this becomes 3 volts as well.
Yeah.
And this becomes 3 volt drop. So it goes from 3 to 0. Okay.
That's crazy.
It is pretty crazy. So Tim's question was, what happens if we stick this to 6? Thinking through this myself.
Okay, so this wire will become 6 volts. So, based on the loop rule, this has to have a 6 volt drop.
Wonder if this one's gonna die. Okay. Here's what I think. I'm curious with batteries. We'll see what happens. Here's my vote. This is gonna get super bright. It might burn out. This is
6 volt drop.
6 volt drop. This one, we're going against this
by 3 volts.
By 3 volts. So this is gonna be a 3 volt drop. I think this will get brighter, but the current's gonna be going this way.
Yeah.
Yes. And you're gonna recharge the battery.
No, no, because that's not how that works.
Ready?
Flashbang.
Ooh, it's not burning out.
That got bright.
Nice.
That got a little brighter.
Yeah.
Okay. There it is.
The more you know.
Actually,
Physics.
I'm actually surprised that can handle a 6 volt drop.
I was too.
I'm so lost.
On the no, this one has to get brighter because current has to switch direction to loop rule work.
So you don't add
Okay.
How did you immediately know that this was a 24 drop, 24 and this was 12? How did you know immediately?
Oh, because they're identical, and so they have to split the voltage drop.
And since this one's also a 12 volt, it did nothing.
Right. Okay.
If it was like a 24 volt though, would have done something.
Yeah, that's what we just did.
That would make it brighter.
Yeah.
Okay.
Okay, so follow-up question. We just switched the polarity of that battery, like how that battery is wired up.
Oh.
So I flipped that.
Oh.
Mm.
Yes.
That's pretty crazy.
Wait, what the heck?
I don't like that.
Shoot, I gotta redo my circuit.
Oh, sorry.
That's okay.
Yeah, I'm okay with that.
Let's see. So
Yeah, I don't like
He's not saying it to you, he's just saying whatever I'm gonna say now is gonna be right.
Listen, they're supposed to be on at the moment.
But when you put this way,
No, they're already on. So A and B, you run A and B because the wording was the word.
Before the switch is closed or after the switch is closed?
No.
Oh, so I think the wording just with my mutation, I think it's just saying only that one.
Oh, I didn't see that. I'm sorry. I didn't think about that part.
Okay, so only A is on B is on.
I don't think it really turned.
There's still a closed loop on the left.
red.
Yeah.
Okay, if we go based on our adjusted version of it.
Yeah. Just
Because you look at the.
B goes out, B goes out.
A, because that's my grade before max grade.
Yeah, at the end it has to be 0 at the
It's 12 on both sides.
at the
The meeting
the
point.
meeting point of A. Like
Yeah,
the
so
middle
it
of
does
it.
have to be 0.
So that means B has 0 voltage.
Yes, so B turns off.
Alright, so think about it. So you have 12 volts coming out of the battery on the left up to B, and then all the way around on the other side, you have 12 volts on the other side.
Okay, Micah, I'm gonna draw this.
Am I
Okay.
thinking?
Micah, what are we saying?
Well, because you have two 12 volts.
24 at the top. 24 at the
Yeah,
top.
24 here.
Sure.
Yeah.
12.
12, yeah.
No, we don't
No,
know
no,
it's 12.
it's 12.
Don't do that.
You don't know it's 12?
And I don't think it is.
Well,
No, we're talking-
beforehand it's 12, right?
Close the switch. Close the switch.
Yeah, let's just close the switch.
Well, then how are we supposed to figure out what these things
So
are?
at the bottom of
Because I wasn't here,
What?
but I did it. I wasn't here, I didn't show you.
No,
It has
Thank
to be
That's
0
12.
if that top one's gonna be 24.
Well, mark
It's
zero.
12 going in, right? Mark where 0
so mark where 0 is gonna be, like at the switch is gonna be 0.
We have, no,
It
because
doesn't
we have 3
have
batteries.
At
If
the
we're gonna have
switch,
0,
it's
it's gonna be 3 batteries. So it can't be, so
That is-
it has to be 0 for it to be 24 at the top.
No, it's not. It's gonna be 12. Yeah, there's a 24 drop across A, it's 12 across B.
Wow, and then 0's in the middle.
Yes.
So 0.
Smudge.
But we're 0
Oh.
here and then we're 12 down here.
Thank you. I'm sorry.
No, how did
All right, Tim. Let's
Is that what we're thinking?
let's work
How
together.
does that even work?
Okay.
Okay, we're gonna start with the switch open and then close it.
Because you can just.
I don't agree with Steve.
Yeah, you can't. You can't figure out the change if you don't know the.
So when they're like,
But it doesn't add, it's just.
Okay,
when they're like perpendicular, like you don't add them, like I thought you didn't, but then like over there you did.
Anytime you want 0, so this point's 0, so 12,
Perpendicular.
24,
What?
Perpendicular.
Like when they're like that, like
Parallel?
if they're
then
yeah, like
In
in
series,
parallel,
in
like when the
series.
wires are perpendicular,
0. Okay.
like right there.
This part's 0. This part's 0, we don't control.
Like yeah, when they're in parallel.
That would be true.
The batteries.
Yeah.
You add them. They're in series.
This being the higher one, this
No,
has
like
negative.
no, you're like not understanding my question.
Negative 12.
You're right.
Like there's there's
And then,
voltage
then when we close that,
from
we
like
end
the
up-
battery on
we
the
end up-
left, and then
So
like
this has a 36.
not for this. Like I understand this question, but the last question, like when it was like switched and like goes up, and then like there's like a split. Like how do you know which is like what do you do with that?
I don't think anybody does.
So we knew that it had 12 from the other side, from the right side, not the left side.
Yeah.
Because all
How about Smiley just
all the wires connected, all wires, assuming there's no resistance, have the same electric potential. There's no potential drop, so it all has the same electric potential value. What?
But I'm saying like if it's 12, like how do you or like over there when they weren't the same, like you like added them. Like well like how do you like why wouldn't you add them? If it's like or like I understand why it's like you don't add them if they're both 12, but like over there like they weren't the same, like you like switch them, and then you were like oh now it's going 3 volts like this way. Like how do you know that?
So I'm looking when they weren't the same, like there's 6 over here. So that means there's a 6-volt gain. Like so this is 0, this is 6. Over here, it was 3. It was 3 volts. So you have there was this had a higher elevation than this one did. So it wants to go to a lower. I mean, you have to look at the whole loop. Like, I don't just look at it and know. I want like I don't know the answer to this. I don't remember it. I'm gonna have to walk through it myself. So I just pick a spot, and then
Then from this loop, we're going to. Okay, then from this
Smiley,
loop,
this marker's dead. I'm gonna toss it, alright? Did a little like.
12 volts. Okay,
sure.
so no, this is 0. So no, okay, so.
All right,
Smiley just teaches us.
here we go. So what votes are on? Well, I guess it doesn't matter. Okay.
I'm gonna say A has to be brighter than B, or B turns off. It's one of those two. Okay, A is brighter than B, and what is technically true if B is off.
Okay, here we go. Here we go. I'm gonna pick. Now this is. You have freedom to do this. You can pick your ground 0, your electric potential to be 0 anywhere you want to. Okay. I'm gonna pick it right here. It doesn't matter. I'll pick it over there next time. Okay. So I'm gonna say this is my electric potential 0. So all along here, this is 0, and I'm allowed to go negative. Like that's fine. Okay. So this is 0 electric potential. All these places along here have electric potential of 0. Okay. Okay. It's all connected by a wire. Okay. Now here I've got 12 volts. I gain that. Here I have 24 volts. So all along here I have 24 volts. Okay. Now before the switch is closed, this is going to be 12 volts here. So there's 12 volts here. Okay. Is everybody okay with that? Okay. Now there is negative 12 here because I'm going in the opposite direction. Okay, I'm climbing down my ladder. I'm climbing down a ladder, so I have below, and this is fine. It's just like having negative gravitational potential energy. It's not illegal. Okay, it's not necessarily what we do. So here we have a 24 volt difference across that. Does that make sense? No, it doesn't arc. So when we connect this, there will be flowing, and that makes this whole, all of this, No. That'll make all of this. I'm gonna say I'm guessing. I'm gonna go on this. All of this negative 12. So
Wait, when you
when it's closed,
Wait,
when this is closed,
so B goes backwards now?
hold on. I'm working through this myself. Okay, so in every loop, you have to have voltage gain equals voltage drop. Okay, so here I've got 24. I've got a voltage. I've got voltage drop of negative 36. Okay, and here I have a voltage gain of 12. Okay, and so that works. Okay, here I have a voltage gain of 12 and a voltage drop of 12. That checks out. Okay, if I go all around the circuit, 24 gain, 36 drop, 12 gain. That checks out.
Smarty, how did you know? What was your thought process on calling? Like, do you just know that across a wire it's not gonna have any voltage drop, so you just guess that at the little key point it's gonna be negative 12?
Yeah, like
It doesn't mathematically work if you keep it being 12.
So let's say I pick this point to be my 0. That'll probably be intuitively better. Okay, so
Oh yeah, because you're going.
so let's say this is 0. 0 volts here. Okay, so before the switch is closed, I just picked that spot to be 0. This is going to have a negative 12 volts. So this is negative 12. This is negative 12. Okay, because this is 0.
No, 12, right?
It's 12. Positive.
No, sorry, this is while the switch is open.
Oh.
While it's open. Okay, so this we drop 12 volts. So this is negative 12. This is negative 12. This is 0 volts here. This is positive 12 volts here. So you have positive 12. So you have 12 volt drop, 12 volt drop. Okay, and oh dear. Oh dear. Hold on a second. That's not 0. This is negative 12. I agree with that.
So it have to be negative 24 because of the battery.
Yeah. Better go with it. It's still 24.
Oh yeah. So negative 24 volt drop. Yeah, I agree with that. Okay, so when we connect that, that makes this
0.
it's a negative 24. Whew. And we get the same shift. Okay, so now I was just going to summarize. So what happens is the current initially was going this way. That was my initial current, was going this way. After I closed the switch, the current now is going goes this way.
So let's go to the junction.
Okay, bringing them back. Positive 36. This gained. So it's going this way.
There's a junction to split as well.
So it goes like this. But why does that stay on? Ah!
The junction there.
So, oh yeah, because it does this. Yeah.
Will we see circuits any more complex than this on the AP test? Or is this kind of the
No, this is how, yeah, this is the complexity you get.
this is the type of thing we see on a